Yeah, what's going on, guys? How's it going? Afternoon, everyone. Laurie, John, Sean, how's it going? Hope you're doing good. Thanks for jumping on while I'm doing this. So I just on the bench at the moment have a little Sundown SAZ-5000 that absolutely shat the bed proper badly. Full rebuild, and I'm just kind of sitting here freaking putting resistors in and stuff. A little bit bored, so I thought I'd jump on stream. What's your thoughts on the Sound Digital Evo 12K? The Evo X seems like a little bit of an improvement over some of the older stuff. No, the Evo X, a little bit of an improvement, but it's still based on the same circuitry. It still runs the components super hard, super close to their breakdown limits. Not the biggest fan of them. They're okay. If I had to choose between running one of those or running a Banda Viking 15K, I'd probably run the Evo X, to be honest. But I don't know, they're not the most. I haven't had the most best experience with them in terms of reliability. You know, people running them and then just failing for no reason. Banda Elite 4000.4. No idea. Never seen it, unfortunately. That's a new name for me. The Banda Elite 4000.4. I might have to look into that. Suggests that it's a 4-channel. Is that like a 4-channel with 1000 watts per channel? That sounds pretty crazy if it is. Would love to see a guts picture if there's one floating around. I should try and stay on top, shouldn't I? I should try and stay on top of like news and new releases, so that when you guys ask me, oh, what do you think of this? I've actually got an answer for you. Truth be told, I only really have an opinion on amplifiers if I've repaired them. Because if I've repaired them, then I've seen them, I've gone over the circuitry, I know how it works. Whereas if I haven't really worked on it, I've got limited knowledge, just based on pictures of what it looks like online. So Taramps are doing the same amp. I doubt it. Taramps and Banda are both very different companies, and they both design their amplifiers from scratch in-house. I would be very surprised, I'm not saying that they're not, but I'd be very surprised if they were offering the exact same circuit. Because they do have their own engineers, and they do use their own engineers, and unless they've done some kind of collaboration between brands where they've shook hands and said, hey, you know what? Let's both use this same circuit design, we'll both design it together. Unless they've done that, I doubt they're using the same circuit. Insert FET, solder, repeat. Adam knows the deal. You know what about that life. You know about that population life. Population density vibes. How's it going, Adam, my friend? I haven't heard from you in a long time, buddy. I'll have to catch up at some point, find out how you're doing. Hope everything is going well for you. Sheesh kebab. There is not any IRS 21844S drive ICs on the market anywhere at the moment. So I'm going to have to use some that I've got in my inventory. I think I've got some. I've got some of the older IR 21844s. So basically, if anyone cares, is interested, the chips that these amps use, which are the most common sort of half-bridge drivers that these Koreans use, they came from the factory with IR 21844S. And International Rectifier made us a revision to that chip, the slightly better version. It's basically the same chip, but some small revisions, which is the IRS 21844. I think the IRS has a bootstrap diode built in, if I remember correctly. So there's one of them's definitely got a diode that some of the others don't have. But anyway, neither of those are available to buy. I've got some of the older versions, the IR 21844s. So I can maybe try and use some of those. They should work fine, provided they're legitimate ones. I bought them from a reputable place, so they should be okay, but you can never be too sure. I've also got some IX 21844S. IX, different manufacturer, but the same chip, basically, the same functionality. I can't say for sure whether I've had good experience with them so far. Problem is, when you repair an amplifier, if it fails again shortly after repair, you never really too sure what caused it. You can never really be absolutely certain because all the parts fail in some kind of cascade butterfly effect, and you're never really sure where it started. Unless you had the amplifier hooked up to data monitoring equipment at the time, that when you were probing all of the drive waves from all of the all of the banks and everything like that. Unless you were probing basically everything, it's almost impossible to know what caused an amplifier to fail. And I have trialed some of the IX chips. In a few amps they worked fine, but I think there was 1 or 2 amps where the FETs died on the bench, after first power up, running it for a minute or so, and the output FETs just failed. And like I say, it could have just been all sorts of things. Could have been dodgy FET from the factory, could have been one of the bootstrap diodes gave up but was reading fine but eventually gave up because it was internally damaged from the original failure. Or it could have been that the circuit didn't like the IX chip for whatever different characteristics it exhibits over the original IRS chip. And it's very hard to be sure on that. It's very hard to really know for sure. So I have some IR 21844S chips that I'll probably be using in this, although it is tempting to use the IX because the IX chips are readily available, or they were the last time I checked. So if I can confirm that they work, then it's great because I'll be able to use those going forward. But I don't know if I trust them enough yet. This is quite an expensive repair for the customer. It's quite a big amplifier. Lots and lots of FETs that can go bang if the chip isn't compatible. So I don't think I'll be risking it here. It's a 4-channel. Nice. Sounds like it's pretty powerful. Send me a link to some guts pictures if you can. If you're allowed to send links in the chat. Don't know if it works or not. What up, Sam? How's it going, promo? Same rating. Interesting. Yeah, it might be the same rating, but a bit different circuit probably. How's it going from New Mexico? Just playing with my new DATS V3, interesting tool, yeah? Yeah, they're pretty fun to play with. You can learn a lot from an audio system just by running impedance sweeps and playing around with it and making small changes to the box or the driver and running the sweep again, seeing what changes. Really, really interesting kit. Tornado, I'm glad you're enjoying the series. Good to hear, buddy. Have you considered sourcing parts and building your own amps? Absolutely, man, for sure. But the amount of knowledge required to design something from scratch is leaps and bounds beyond just basic troubleshooting. I am good at troubleshooting. Like that is my skill. Whether it's electronics or basically anything, I'm quite good at finding faults, finding what's wrong, thinking logically, and making it work again. But the knowledge required to design a circuit from scratch is on a whole nother level. And I entered the electronics world with a repair kind of tunnel vision. So I'm good at repair, but I wouldn't necessarily know a huge deal about component choice, and I don't know the intricacies around how specific circuit clusters work. I know how they work, I know how they should work, and I know what it looks like when they don't work and how to make them work again, but I don't necessarily know the design choices that were made to initially design that part of circuit in the first place. So that's the information and the knowledge that you need to design something from scratch, and I'd love to do it at some point, but I'm just not there yet, So basically, guys, if you live in the UK and if you know anything about the Digital Designs 712s, the old ones with the red stitching, absolutely fantastic subs. They were really, really great subs, and a couple of buddies of mine were able to hit a 161 at low frequencies with like a bunch of them. They're really, really great drivers. You can still get them in the UK under a different brand, under the In-Phase Power Drive brand. They're exactly the same sub, just with a different logo on the front. My man here in the live chat, Sinewave02, is doing a giveaway. So if you live in the UK and you want to get your hands on one of the 15s, the 715 or the Power Drive 15, fantastic driver, then yeah, feel free to drop in the details. Sinewave02, there's a giveaway. You just click on the link and you can enter the giveaway, and because you're watching my live stream, you get an additional entry, so you get 2 entries, so you double your chances of winning the sub. And it's it's worldwide. It's a worldwide giveaway. Screw it. So even if you're not in the UK, you can win a Power Drive 15. So the code to enter to get an extra entry is Stanky Fets, which I'll put in the live chat just now. Enter Stanky Fets. I think that was right. Or was it Skanky Fets? Stanky Fets or Skanky Fets? Yeah. Skanky Fets. Oh, it's with a K. Let me delete my comment. Remove. There you go. Skanky Fets with a K. So enter that into the giveaway, and you get an extra. You get an extra entry, which is cool. Adam Francis, yeah man, I'm good, saving for a house, man. That's peak and it's long. Building the van, yeah, I see your videos, man. This looks like a freaking headache. What a piece of shit you ended up buying. The issue after issue, man. Someone gave me some verbal bants on a vid, so I need to make some content and get some rivalry going. That's a good shout. It's actually having like banter between two channels and having a little bit of like fire going backwards and forwards, friendly fire, is actually good for both channels. Any how do they say it? Any, not marketing, any publicity is good publicity. So yeah, if you've got some kind of good banter going on with Salman, that will benefit both of your channels, I'm sure. That's sweet. Good to hear, man. I'm glad you're doing alright. How is the Auna project? What is the Auna project? Don't think I know is that a project that I started and forgot about? Because I wouldn't put it past me, to be honest. The link for the Banda is not coming up. You can Google search Banda 4000.4 and the guts show up. Alright, sweet. Let's take a look at the Banda 4000.4, bruh. It's probably going to be a Class D full range. What are we saying? Peace then go. Peace then go. Peace then go. Okay, let's have a look. Let's have a look. What are we saying then? If this page will actually ever load. Alright, here we go. So what are we saying? We're saying 4 times 1200 watts RMS at 2 ohms. Nice, nice. Yeah, 2 times 24. Bloody hell, that is a lot of power in a small chassis. Obviously 4 channel. That's a great option actually for all these people that have got ridiculous numbers of PA speakers firing out the doors, you know, wanting to play to a crowd. That's a lot of power from a 4 channel in a small case. Love it. Let's see. Oh no! Is that using the 2093M? I have mixed feelings about this. Okay, so this is a great... No, this chip is great. Okay, so we're not going to get a nice zoomed in picture probably, are we? I'll reopen close tab. See, if I click on this one, there's some related pictures where I get a better zoomed in picture. I think this is the only picture that exists. So this right here... Oh wait, we can make it bigger. We can make it bigger. Yeah, come on. Right, here we go. This is the biggest picture we're gonna get. I wonder if I can zoom in on it with paint. Copy image. Oh, it's a bit bigger in MS Paint. Pixel City. Computer. Enhance. So I can't be certain, but that looks to me like an IR2093M. Really great 4-channel Class D drive IC. Love to see it. If it is the 2093M, they are nice. They are great sounding chips. Good protection built in, etc. They only come alive when all four channels are oscillating and bootstrapping and stuff like that. The only issue I have with them in an automotive environment like this is they are a very tiny surface mount package. Now what happens is that the heat and cool cycles of the board in general and the chip just cause the tiny solder connections that this chip uses to expand and contract so much that they get solder fatigue, and the lead-free solder that's used in these boards now actually cracks. I have this experience with the B2 Audio, I think it's the Rage 4 channels and 6 channels specifically that use this drive IC. Yeah, basically the solder just kind of cracks a little bit, and you need to reflow the chip, and then it works again. So it's definitely the solder that's the issue on these. And they're not well suited to an automotive environment where you've got vibrations and drastic heat and cool cycles. You know, cold weather outside in the morning, you turn the amplifier on and the chip reaches operating temperature and it cools down again quickly when you get out of the car. It's a stressful environment for the solder connections. So the chip's fine, but yeah, I'd be a bigger fan of it if it used some kind of through-hole variant of this kind of circuit architecture. I think that one of the reasons that so many of the older car audio amplifiers were so reliable and just worked for years is because they utilized through-hole components, therefore almost completely mitigating the risk of poor bad solder joints, surface mount solder joints due to heat and cool cycles. Yeah, you can still get vibration damage obviously on through-hole components, but that's a little bit different. That's vibration damage, but rather than just heat and cool. So I would like to see a amplifier that was a newly designed amplifier using new technologies, new chips and stuff like that, but that was using, if they exist, the through-hole variants of those ICs. I know that it would increase the manufacturing costs a bit, it maybe increase the size of the board a little bit, whatever it is, but I think it would just be a lot more reliable. So yeah, we've had a look at the what probably is the drive IC. It could not even be the drive IC. I could have just said all that, and that could not necessarily be the drive IC. That could be the MCU. That could be the PIC, the controller. Actually, you know what? Completely take back everything I just said. The fact that this has these little headers next to it, see these? This is going to be the MCU. That's not the drive IC. Nope, that is the MCU. So, how do I feel about amps using MCUs? Well, I like it in some aspects because the protection circuits are usually very fast. You can program the MCU for a specific switching frequency based on the transformers you're using. There are some benefits to using an MCU like this. However, Banda are not one of the companies that have a particularly good track record in terms of customer service and repairability. I have tried to contact Banda on multiple occasions to get MCUs for their big amplifiers like the Viking 15K, and they will not respond or provide these MCUs. So much to the point where I got a guy over in the States who actually programs his own replacement MCUs for the Banda Viking 15K specifically that kills the MCUs when the power supply FETs die. Yeah, he's basically had to reverse engineer the firmware and program new chips for them because Banda will not supply them. In stark contrast to that, Taramps are absolute fucking legends and will send out new MCUs programmed generally for free. I don't know if they started charging now, but they were sending them out completely free of charge. Big respect to Taramps for that. So obviously that makes it very easy to repair them. However, one thing to bear in mind is that these companies may not offer that indefinitely. So, you know, maybe like 10, 15 years down the line, if you're running an amplifier that has an MCU that needs a replacement, if the brand no longer offers those MCUs as a replacement, then you might be kind of stuck with a bit of a doorstop, or you might have to reverse engineer something yourself, which is not easy. So, yeah, I'm a bit torn. I do prefer seeing sort of like discrete self-oscillating kind of, or like PWM generators like the TL494 is tried and tested, like the SG3525 that the Powerus uses. It's one of the great things about the Powerus amplifiers. They don't use an MCU, they use an SG3525, which you can buy for like pennies as a replacement, and they barely ever die anyway. So there's plenty of great protection options built into the 3525. There's very flexible dead time duty cycle options on there. It's a great PWM generator for power supplies in cars. So I'm a big fan of that, and I'm glad that they used the 3525. Anyway, what is the output section then? Looks like we have, oh wow, only 2 MOSFETs per channel. So we've got 2 MOSFETs, and they are going to be responsible for 1,200 watts each. Damn, they must be some pretty beef-ass MOSFETs. I'd love to know what they're using. Probably like, what is this? It's going to be relatively low rail voltage, so probably 4115s. Yeah, it's probably 4115, something similar to that. So that's cool. We've got the driver. This is the output driver for the for each channel. But because it's on a daughter board, I can't actually get a good view of what's on there. It's probably going to be a 2092. Let's be honest, that's what they're all using. 2092 is a great Class D driver. Sounds great. It's got very clever protection built in. Yeah, the 2092 is a great Class D MOSFET driver, and that's probably what's being used. But it is kind of hard to see, hard to tell. But we've got a chip there. You see, that's the chip there. We can kind of count the legs. So it's either a 2092 or a 20957. 1, 2, 3, 4, 5. Oh, 1, 2. Hang on a minute. Let me just grab this and see whether I can like shift it along a little bit. So that's the size of the pins. If I paste that up here, you can kind of get an idea as to, so if I put that pin in line with there, paste again, so is there 1 or 2 pins that's going to be alongside that? Just the 1, I think. Yeah, so we've got 1, 2, 3, 4, 5, 6, 7, 8. So it's a 16-pin IC. And the IRS2092... Actually, are they both the same amount of pins, or has the 20957 got more pins? I feel like one of them's a 14, one of them's an 18 pin, but okay, so 16 pin on the 2092, IRS20957S. Are they both 16 pin? Probably are. So it could be either of them. Yeah, it could be either of them. So it's either a 2092 or a 20957. Not too sure. So that's cool. What else do we have going on here then? We have a couple of nice big film filter caps. There's the output filter inductor. They're using the standard Brazilian style output for a 4-channel. So you've got basically a common left negative, right positive, and then the right negative will be an inverted positive. It confuses the hell out of some people, but it makes perfect sense. So you would shove the plus and minus from left and right into this middle one, which is common ground, and then the others will be, I think actually the common ground is going to be this one over here. It looks like it's connected to the ground trace. So you got, yeah, your common ground over on this side, which you'll put your left and right plus and minus into for the ground, and then your active ones you'll have left side positive and right side negative will be active. It's pretty standard. Got 072Cs in the preamp, low, flat and high. It doesn't look like you're going to have any manual adjustment for that. So you have fixed low pass and high pass frequencies. That's fine. Most people are using a head unit, DSP or something like that for those functions anyway. So at least you have the options there. These FETs look kind of interesting. They look like they've got a shiny front there. Got some fans. You got 2 fans. These are intake fans, so you're going to have intake blowing over the FETs. I'm not a big fan of that, no pun intended. You're going to get a lot of build-up of dust and crap on the MOSFET legs here, so not a huge fan of that personally, but it is what it is. Actually, these are, no, sorry, these are TO2, these are 247 AC size parts. Okay, I thought these were TO220. These are big. These are big chonky boy FETs. I don't know what they're going to be actually. Lowest rail voltage in this amplifier probably 1200 watts per channel. I wonder what they're going to be. Yeah, I'd love to figure out what they were. But the marking is actually covered up by this. Oh crap! I've not actually been sharing my screen here. Sorry about that. How long have I been not sharing my screen for? Shit. I don't know. Anyway, so yeah, like I was saying, fixed low and high pass filters, TO074Cs in the preamp, fine, nice sounding chip, film caps and output inductors for each channel, drive circuit here with either 2092 or 20957S. Looks like we have some voltage regulators here. That's probably a voltage reg. That might be a voltage reg. Another one there. Going to have probably plus minus 15 volts somewhere, and 12 volts reference negative rail. We do have plus and minus rails, as you can see here. The rail caps are turned away from each other here. So you're going to have positive rail here, common ground here. This is going to be a common ground here, along these. So you're going to have positive rail here and here, and negative rail here and here. So it's not going to be using a single positive rail voltage. Got bipolar rails. There's your power supply drive IC. The MCU is going to be creating pulses for those drivers. They're going to be 4472s or something along those lines. Here we go. Here is some auxiliary voltage supplies. So you've got some little auxiliary taps off of the transformers here. And they're going to be feeding into some rectifier diodes, which are these. Some smoothing caps, which are these. Those traces probably go off to these, maybe something like that, but depends whether they need further regulation or not. But yeah, that's some auxiliary voltage supply there. Power supply wise, yeah, looks pretty good for a, well, this is a 4K amplifier essentially. So they're going to be 3077s or 428s, which are like a Brazil only parts. You can't really buy those, very difficult to get a hold of. But they're basically a 3077. What else have we got? Interesting, I wonder what these are. So if this is the MOSFET driver, what are these? Can we see where the traces go? Traces from the FETs come up and... looks like they go into here as well. Looks like they've got further buffers. So what's this chip doing then? Let's tell where these traces look like they go here. So it looks like we've got like a MOSFET drive IC, but then further final buffers. Interesting, because these drive ICs are very powerful, more than capable of driving, what, 12 FETs here? I wonder why they've done that. I'll have to actually check it out and see these part numbers, but if that is a 4427, why would they have further buffers, but we don't have any over this side? So maybe they're not final buffers, but it does look like they go to the FETs. Trace there. Oh no, maybe it doesn't. Maybe it's actually what we got here. Remote input terminal. That trace goes round here. That's this trace. That goes over there. That's not that. So the remote terminal one goes over there. The gate path one is this, and that goes into this diode here. Round there, underneath the transformer, maybe round to here. So yeah, I'm not too sure what they're doing. They're unlikely to be final buffers because you don't have any over this side, unless you've got, yeah, no, you wouldn't. I'm not too sure what they're doing. The rectifiers for the main rails are under the board. That's pretty standard Banda practice. There's 4 there, main rectifiers for the rails. What else can we talk about? Not much else really. That's about all we can gauge from looking at the PCB, I'd say. Probably some protection circuit stuff over here, possibly. Yeah, looks alright. Right, what was I doing on this board anyway? I had just done the gate resistors. Problem is, I was planning to like repair this amp nice and quickly, but I've turned on the live stream and ended up spending about half an hour looking at the new Banda amplifier. Right, so all new gate resistors are now fitted in this Sundown. So I need new drive ICs now. Right, awesome. Let's get some new drive ICs. Have you ever worked on an Eclipse amplifier? No, I haven't, I'm afraid, Tyler. Not really seen one of those. I don't think we have many of those in the UK, to be honest. How did it go with the Rockford DSPs? I haven't done any more work on the Rockford DSPs. Maybe we'll do that a little bit later today if I get time on the live stream. I've run it with the EQ card out. So, right, gentlemen, if you followed my live stream the other day where we looked at the Rockford DSPs, the processors, this right here in the live chat is the customer. This is the owner of those all those Rockford processors. So basically, he's got a fourth one, which I think works. And he was going to test it for me to see whether there was any audio output from the DSP when the EQ card wasn't installed, when the graphics equalizer daughter board wasn't present. And he says couldn't get audio even through the setting on the RDAM. Must be jumpers inside for card in and card out. Makes sense to me. So, okay, looks like then when we're testing the DSPs, we're going to need to actually have the EQ card fitted. So that's something that we didn't know yesterday. I think someone was suggesting that they could be run without them, but I didn't change any jumper settings because I don't know about that. So that's good information. Thanks very much, Kenneth, for that. Okay, so in this amplifier, the NPNs are in the middle. Cool, cool. Love to see it. So we're going to need those firing forwards. Got 139s in the NPNs and some beefy PNPs to go in this one. The PNP drivers I'm fitting to this board are beefy enough that they shouldn't die even if the power supply section fails again. They should be able to handle the 12 volts getting fed back through the gate resistor, and the PNP drivers that I fit should be able to sync that voltage to ground without actually dying. So we'll see how that goes. It's in theory anyway. I mean, I'm not planning on this amplifier dying again, but you've got to prepare for every possibility. Just kind of trying to catch up on a little bit of live chat right now. You guys have been chatting away while I've been looking at that stuff. Tapped horn sucks in general. I'd love to have a discussion about tapped horn. So I'm not a enclosure design extravaganza extraordinaire boss man. I know a reasonable amount about enclosures, but I'm not the best designer, and I'm not very experienced with horn resp, which is the fantastic piece of software that you might want to use to design a tapped horn, for example. My man from Harwood Acoustics would be the best guy to talk to about that. And I have huge respect for my man at Harwood Acoustics and his knowledge. And he is a big fan of tapped horns. So because he's a big fan of tapped horns, I hold them in relatively high regard as well, because there's going to be a reason that he's a fan of them. So the PNPs I'm using are BD676s. Apparently these should be able to survive a catastrophic failure of the power supply in the future. But yeah, because he's a big fan of them, I understand them to be, I assume that they are one of the better enclosures to design, provided you've got the space for them. So it'd be super interesting to have a discussion between experts on quarter wave boxes about their benefits and drawbacks. Sam, I don't know how good you are with computer PSUs, but a large company called Tech Power Up, who does reviews, are looking for someone who understands and can write reviews. Yo! That is a solid shout from my man. Thank you, Mr. EE100. Man, I might even check that out. I might even crack open some computer power supplies and go through them with a fine tooth comb just to kind of boost up my knowledge a little bit and reach out. That would be a good shout. And they can obviously check out my YouTube channel to see my presentation process. Well, I don't know if it would it be a video or would it be just a write-up? I'll have to check that out. And can write reviews. Okay, so it might be written. That's fine. I can do written. Might employ ChatGPT to do the written part for me, just so I've got some spare time. But hey, I can give it some pointers. Be like, this is good, this is bad. Write me up a nice review. But nice. I might even reach out. If they were wanting to do video reviews, that's right up my alley, of course. Yeah, that sounds sick actually. I'd love to do that. That'd be so cool. get a bunch of different computer power supplies, load them heavily, make sure that they can consistently supply their rated current across the rails, all rails loaded. See whether any of them are underrated, see if they're overrated, see if any of them explode, see how clean the rails are. That's another important thing. See how much noise is on the rails. Yeah, that could be a really cool little side project, man. Thanks for that idea. Love that. Do the tapped horn anytime soon for Boom or Bust series. So basically, for Boom or Bust, I can only do what's been submitted. I'm not designing enclosures myself for Boom or Bust. I literally don't have the time. So if anyone wants to design a tapped horn for Boom or Bust, then be my guest. I'd love to do it. I'd love to do a tapped horn. I really want my man from Harwood Acoustics to submit a tapped horn, because I think he'd be one of the best guys to design one for that. But he is getting to grips with CAD. He's like an absolute legend with drawing, like technical drawing. It looks like something you'd print out of a printer. He's so skilled with pen and paper. But it's just getting those skills translated to CAD and on the PC. So he's working on that at the minute. So hopefully we might get a submission sometime soon. But we'll just have to wait and see. He's a very busy guy, so. Let's get these drivers soldered in. Mr. E says, Sam, the jumpers J1, J2 and J4, 5 have to be used if you have balanced inputs, but there is no mention of jumpers being used if you just use the RCA. Yeah, so I was using the RCA yesterday. I did shift one of the jumper positions actually to unbalanced. I'm assuming that, just for testing purposes on the workbench here with RCA input, it's going to be unbalanced. So yeah, I did flip the jumpers to unbalanced. Oh man, doing a full rebuild of one of these circuits, so many solder connections, right? Hey, who wants to do some quick maths for me, okay? There are 32 power supply MOSFETs. Each MOSFET has 3 legs, so 32 times by 3. And then you have to desolder the old ones and resolder the new ones. So that's 32 times by 2 times by 3, because you have to, times by 2, because you have to desolder and resolder each pin. So I don't know whatever the heck that is. Then you've got, each MOSFET has gate resistors. So then you have 32 gate resistors. Each gate resistor has 2 pins. So that's 32 times 2 times by 2 again, because you have to desolder and resolder. Then you've got the drivers. You've got 16 drivers. Each of those has 3 pins. So you've got to desolder and resolder again. So it's 16 times by 2 times by 3. So you add all those together, and that's just a power supply rebuild. How many legs have I soldered and desoldered so far? It's hundreds. It's a mission doing these full rebuilds. This is only a 5k. Imagine doing like a 10k. 10k take even freaking longer. Alright, I think we're good. I think we're good on those. So let's cut the legs of these. Bevis, do you think there will be any new half-bridge designs using modern parts, or will everything be full bridge in the future? I personally, I hope that everything will be full bridge going forward. The reason I say that, and it doesn't matter about whether it's half bridge or full bridge, has nothing to do with how the amplifier sounds or how reliable it is. It's literally just whether you have a sine wave on just the positive or whether you have a sine wave on positive and negative. That's all it means. It doesn't mean anything about Brazilian circuits, have nothing to do with Brazilian circuits. Full bridge amplifiers have been around for years, as you full well know, in the likes of the JBL Slash series, Alpine PDX series, and the MRV series. Yeah, basically Rockford, all sorts of stuff. The reason I think full bridge is better for subwoofer application, for high power subwoofer application, is reason number one. Because full bridge uses push-pull on the output terminal, the rail voltages need to be only half what they would otherwise need to be for a half bridge. Having lower rail voltages generally means that you are more within the high power band of the MOSFETs. Regardless of what MOSFETs you choose, the actual amount of current each MOSFET can pass massively decreases as the voltage goes up. And if you look at the data sheets for many MOSFETs, even though the MOSFET might say that it is capable of passing 80 amps, that's only with a very low voltage across drain and source. And once you start getting up to, 3/4 of the breakdown voltage, that amount of current that the MOSFET can pass is now literally a tenth of what it stated it could do. So having lower rails means that MOSFETs that you use can run more efficiently because they are more within their kind of happy operating range where they're able to pass high current through them, making best use of their low RDS. Second reason I like, it's kind of reason 1.b, is lower rail voltages means that there is less noise introduced into the signal from the Class D switching, because the Class D switching is much lower amplitude because the rails are smaller, therefore you get a less noisy kind of output. You got less spikes, less ringing, less kind of nonsense to deal with because the voltages are just lower in a full bridge than compared to a half bridge. Second reason I like full bridge for subwoofer application is because there is no bus pumping. If you want to Google bus pumping, you can do to understand what it is, but basically when you've got a half bridge amplifier running at very low frequencies between 20 and 40 hertz, something called bus pumping can happen where the rail voltage at specific frequencies under certain circumstances is kind of bolstered when the current is drawn because of the oscillation of the frequency tied to ground. You don't get that with full bridge because there's no pathway to ground per se. You've just got a kind of push-pull environment going on, so there's no bus pumping with full bridge, which is much better for the amplifier. So yeah, there's a couple of reasons I prefer full bridge for subwoofer application. Third reason really is the only reason to have a half bridge is so that you can strap two amplifiers together. Now, because power has got so cheap and because electronic components have got so powerful, there's no need to strap amplifiers anymore. Yeah, I get it, back in the day when the biggest amplifier you could buy was maybe 2000 watts RMS, to get 4K into a common load, strapping two of the 2Ks together made sense. Hey, that's a great idea. Yeah, awesome. But now you can get like a 15,000 watt amplifier and it's not really that much bigger than, the old half bridge 5K, or so, you know what I mean? It's like relatively compact. for like ridiculous amounts of power. So you don't need to bridge amplifiers anymore. If you're running that much power, say you needed 30k, you're not going to get 215s and strap them, because if you're running 30k, you're going to be running multiple subs anyway. There's no single voice coil that will take 15k clamped, so you're going to be running multiple subs or multiple voice coils at least. That means that if you need to run multiple amplifiers rather than strapping them, you just run an amp per sub or per coil, split them up that way. No need to strap and have the amplifiers feeding into each other, adding extra risk and potential damage. If one of the amplifiers was to fail, it takes out the other one as well. So yeah, just yeah, full bridge going forward for subwoofer application, absolutely. For full range, half bridge is still what's used. There's no such thing as a multi-channel full bridge amplifier. It would make no sense at all. It would be ridiculously complicated and for no reason. So all of your Brazilian 4-channel amplifiers and 2-channel amplifiers are all half bridge still. The only ones that are full bridge are the sub amps. What about the big Korean full bridge amps like the Salt 12K, 12 and the Pitbull 20K? Yeah, so basically what they are is they are two of the Korean half bridge design, but strapped on the same PCB. So they're not really a true full bridge in a sense. They're not, you know, the actual drive circuit architecture is half bridge drive circuit architecture. It's the same as if you had two of the, I don't know, two 6Ks or two 10Ks, and you strap them externally, but they've just put it all on the same PCB and given it a common power supply. So it's kind of full bridge, but kind of not. You do still have the benefits of full bridge by the fact that the rail voltage is half what it would otherwise be for a half bridge 20K or 12K, whatever. All the rail voltages are the same as if it was a 6K or 10K. So there is that benefit there, but it's still an older circuit design. It's still an older architecture. What about the Doomsday amp from Devbont Sound Digital? I can't remember exactly what that one is. Is that the 35K one or the 20K one? Quad feed, yeah, so the difference in sound you experienced there was literally just a preamp circuit. That's all it was. The Sundown amplifiers have a very sharp and steep low pass filter, and it goes very low on the dial. So yes, the difference in sound that you experienced between your Sundown and the Sound Digital was literally just a preamp, and that can be corrected. The sound difference as a result of different preamp settings is not a characteristic of the amplifier. It's just a characteristic of the preamplifier slopes, and you can correct that either before the amplifier or on the amplifier if you know how to turn the dials to correct settings. But yeah, you know, if you were using you know, some kind of head unit that had a low pass filter built into it, then you could use the low pass filter on the head unit and get the same sound between the two amplifiers. Or, you know, some kind of, yeah, I say use a DSP, but DSP is a very expensive way to make a Brazilian sound like a Korean, so I don't really, you know, recommend that. That's not the, you know, you use a DSP if you're wanting to have other benefits of the DSP, like time alignment and per channel EQ and all those other features that a DSP offers. You don't buy a DSP to make your one amplifier that has a less than ideal preamp circuit sound like one that has a better preamp circuit. That's not what you'd use a DSP for. You just use an external active crossover for that, or the head unit settings, or whatever it is. Yeah, Dayton Audio do have quite a cheap DSP, but it's still an expensive way to turn, it's still an expensive way to correct basic preamp functions. That's not what you should be buying a DSP for. I could say that would be like buying a Haltech ECU just to give you some steering wheel controls for your stereo. You know what I mean? Like, Strictly Amps, how's it going? How's it going? Thanks for jumping on. Always appreciate seeing other technicians jump on the streams. How do you phase match multiple terms in a big setup? So basically, the only reason, or the main reason I've found that amplifiers or Korean amplifiers can be different in their phase on output, the phase can be off from each other, is just because of the presence of the phase adjustment circuit in the first place. So the phase adjustment circuit being present causes there to be variances between amplifiers, even with the dial set to 0. Just the fact that the circuit's there means that there can be variances in the phase with the dial set at 0. Now the Teraamps amplifiers don't have phase adjustment circuit, so as far as I'm aware, based on what I've seen, they should all be within perfect phase of each other, because there's no components on the boards which should be throwing the phase off between PCBs. Whereas the Korean ones that do have a phase adjustment circuit can have different component tolerances in the phase adjustment circuit that cause the phase to be off even when the dial is in the same position. So you shouldn't run into any phase issues using amplifiers that don't have a phase adjustment circuit. Don't take that as gospel. I haven't, confirmed it with every single amplifier that doesn't have a phase adjustment circuit, but that's just my understanding from what I've seen. I think I got the height about right on these. That was the original FETs. Yeah, it looks about right. Quadfi says the lows were not similar at all though. So the reason that the lows were probably not similar, did you have the high pass filter on the Sound Digital set to absolute minimum? And to be honest, even if you did, the Sound Digitals I've noticed have a fixed high pass filter. It sucks. Even with the high pass filter on minimum, it actually starts attenuating frequencies as high as 28 Hz. So obviously the way around that is just to decrease the low pass filter to a really low value like 35, 40, and increase the overall gain, and that will bring up the lower frequencies back again across the board. But yeah, I agree that it's an annoying way to have to do it, but the Sound Digital amplifiers circuit, the actual amplifier topology lends itself better to low frequency response actually, because it's full bridge, so there's no bus pumping. So the actual amplifier circuit itself in the Sound Digital should, completely void of any preamplifier differences, play low frequencies better than the Sundown did. So at the end of the day, a Class D amplifier circuit, all it is just passing on the sine wave that's fed into it. Like the actual amplifier circuit itself doesn't really have a limit on its low frequency response. A Class D amplifier output stage will very happily play DC. Like It doesn't really care. The thing that stops it from playing DC is the preamp circuit. In fact, a Class D output section is actually happier just sending one of the rails to the speaker terminals than it is switching at high frequency, believe it or not. Now, obviously, the amplifier won't have been designed to dissipate the amount of energy, the amount of thermal energy that sending DC through a load would cause. The Class D section has been designed to, you know, for the output section to be reliable with pulses, not with straight DC. But if you didn't have a load connected, or you had a relatively high resistance load connected, a Class D output section would actually not mind passing straight DC in the slightest. The components wouldn't complain about that. Bevis, I sent a link in your general banter for the PSU reviewer job. Nice one. I assume that's on the Discord. I don't spend much time on the Discord. I tend to forget about it. I actually forget it's there most of the time. But I'll jump on there and have a look. Thank you very much for that, buddy. Yeah, Kenneth has 4 EPX2s, 1 EPX and 1 Symmetry. I love them. I'm glad that you love them, my friend. Kubas says, to turn the phase 180 on my Tarams, can I just switch the places of positive and negative on the speaker cable? Yeah, exactly. Yeah. That's exactly correct. Although, one interesting thing to remember is that flipping the polarity of the speaker wires is not technically the same thing as turning the phase dial to 180. It's actually a bit different, but as far as anyone using the amplifier will be concerned, it will be the same. But yeah, it's technically not the same. An SAZ-5000 in your shop that isn't mine. Ratty cat. Wait, do I know this person? I don't recognise their username. The only thing I can think it might be is Lee. Could be Mr. Riddle. Hey, I guessed right. How's it going, my man? Good to see you jumping on the stream, buddy. Yeah, man. I do still have yours in the workshop, but yes, not yours actually. Not yours. Which is a good thing, because if it was yours, it would mean that I had been testing it and it had died again, so. But no, haven't been testing it. Not yours, fortunately. But hope you're doing good, my friend. Hope you're good. Yes, flip this bad boy over. Check that I've got the height all the same on these. Looks like I have for the most part. Shift that one down a little bit. There we go. Shift that one down a little bit. Yeah, boy. Afternoon from oh man, how the hell do you say it? Ontario, Canada. How's it going? How is it in Canada right now, my friend? Is it snowing? If it died in your hands, I wouldn't be worried. Yeah, no, same. I would literally, any time that an amplifier is going to fail, I would much rather it fail during testing here. Not only obviously does it save money on postage and inconvenience for the owner if it dies again due to some issue, but yeah, it just means that I can identify the cause much quicker and repair it again. Much prefer that. Also, usually when I'm testing the amplifiers, I have some kind of current limiting factor built in, whether I'm using the bench power supply or if I am testing it on batteries or something in the van, I'll run a really low power fuse. At least for like the first few hours of testing, just to make sure that the amplifier is happy and not going to die, you know, idling or running low power. The reason for that is if the output section in these older Koreans fails, it almost always takes out the freaking power supply circuit, even though there's no need for it to do that. So if you run a low power fuse, low rating fuse in line with the amplifier, then hopefully, fingers crossed, the idea is that the fuse blows before the power supply FETs get overloaded fully. So you can actually like cut the repair bill or the amount of money that you need to spend in parts repairing it again in half. Actually, here's a tip for anyone that is still using an older Korean half-bridge amplifier, like a Sundown, a DC Audio, Ground Zero, SPL Dynamics, anything like that. If your amplifier ever goes into protection, do not power cycle the amplifier. Do not power it off and power it on again. If your amp goes into protection mode and the smoke isn't coming out yet and it's in protect, the worst thing that you can do is turn. I know it's tempting. I would be so tempted. If the amplifier went into protect, you'd be like, oh shit, why has it gone into protect? And you try to turn it off and turn it back on again, see if it comes back on. That's literally the worst thing that you can do. The reason is because these amplifiers don't have any current monitoring or any overcurrent protection of the power supply circuit. So if the amplifier went into protect as a result of blown output MOSFETs for whatever reason, it's the most likely reason it's going to go into protect. Yeah, these amplifiers, they only really protect if you send them too high a voltage or too low voltage, in which case you probably know about it because you'd see a voltmeter shoot up to 20 volts or you'd see a voltmeter down at 9 volts or something like that. So you know about that. The only other time it will go into protection is if it's overheated, which you can check. If it's like too hot for you to touch, then it's probably overheated due to, probably in protect due to overheating. But the only, and you're going to know about those. But if it's in protect and it's pretty cold to the touch, and you don't have a good reason why, then it's probably because the output FETs have failed for whatever reason. And if you power cycle the amplifier, then chances are all of the power supply FETs, the bits that I'm working on just now that I've spent the last however many freaking hours repairing, all of these are going to die, and it's going to more than double the repair bill. So the answer, the thing that you should do if your amplifier goes into protect, rather than power cycling it, and I know that it's a mission, I know it sucks, is take the amplifier out, get it inside, or get it on a bench, get it somewhere, take the back off, grab your multimeter, and check the resistance across the output FETs. If none of them are reading short, then you're probably safe to power the amplifier back up again. And it probably was something else that caused it to go into protect. But you'd have to try and figure out why, but yeah. But if you see shorted output MOSFETs, then do not, for the love of God, power that amplifier up again, ever, until the FETs have been replaced and the output section damage has been repaired. I actually had that happen to me once when I was running my LW Audio Korean half bridge 4.5Ks in my van a while ago. I was running a pair of them, and I was on a pretty long journey, and it was in the winter, and I was slamming some bass, man. It was freaking great up in there. And yeah, one of the amps, they were actually running strapped. One of the amps went into protect, and it sent the other one into protect as well, probably. They're both in protect. So when I noticed the bass had cut out, obviously I didn't have protect LEDs in the cabin with me. So what I did is the bass cut out, and I was like, that's strange, my bass has cut out. And rather than turning the remote switch off for the amps, rather than turning the amps off, I kept them on. Right? That sounds weird. The bass has cut out. The first thing you'd probably do is like turn the amps off. No. If the bass has cut out, I kept the amps on, pulled over as soon as I could, and just went and had a look at the amps. I saw that they were in protect. The problem is if you turn it straight off, you don't know if the amp went into protect or not. Unless you've got protect lights up front. It could have been your RCAs broke, or your sub-coil wire tinsel leads broke, something else. You need to be sure that your bass cut out because it went into protect or not. So I kept the amp on, pulled over, had a look to see if the amps were in protect. Okay, they're in protect. Then I turned them off and didn't turn them on again. I actually pulled the amps, both of them, out of the van, put them on the bench, checked all the output FETs. None of them were actually dead. Turns out it went into protect due to condensation. So it was a very cold day and I was slamming the bass, and yeah, just a little bit of condensation built up on the board, and it just caused some of the voltages from the output section, the high voltages, to leak into the protection circuitry itself. So it actually triggered the protection circuitry kind of falsely in a way. Yeah, the protection circuit just kind of got triggered because it was receiving some stray voltages through the condensation from the high voltage output section. So I was like, okay, cool, no worries, put them back in the van, you know, dried them out, isopropyl alcohol, clean them out, put them back in the van, and they continued working absolutely fine. But if any of the output MOSFETs had been dead, and if I had power cycled it, then it might have been a different story. It might have killed the power supply FETs completely. So, alright, I think we have finally fully rebuilt this whole power supply section. So we've got all new power supply FETs in this board, all new gate resistors, all new drive ICs. Just make sure that I haven't missed any solder points or anything silly like that while I've been chatting to you guys. Oh yeah, so yeah, I think this happened with Lee. I think it went into protection, you power cycled it, isn't it? I remember you telling me about that, and then the smoke came out. Yeah, sad times, but do be like that sometimes. Like, when it happened to me, when my LWs went into protect, I was so tempted to power cycle them. Like, even knowing what I know, I was like, yeah, sure it'll be alright. Like, but I held off and I didn't. But I know it's so tempting. You're in your car, you're basing away, the amp goes into protect. The first thing you do is power cycle it. I know. But if you can avoid doing that, you might just save yourself an expensive repair. Now what's interesting is the same doesn't go for the Brazilians. So if you've got a Brazilian amplifier that goes into protect, you can power cycle that bitch as many times as you like. You're not going to kill the power supply section from an output section short because it has proper protection circuit. It has a health check mode at the start. Simple, I know. But you would have thought it would be pretty easy. Well, it is pretty easy because the Brazilians done it. To add a health check mode to the amplifier on startup. Literally all it's got to do is try and build like 2 volts worth of rail. If it gets it, then there's no output short. Yeah, fucking power up then. If it doesn't get the 2 volts of rail during health check, then it knows there's a short or something else is wrong and it doesn't power up. Simple as that. It's not difficult, is it, Korea? And they still don't do it. Even the latest amps coming out of Korea still don't have a health check mode on startup. And they still suffer from this issue. Alright, cool. So, now, talking about power up, I think we're pretty safe to put some power into this board now for the first time since it came into the workshop. I didn't even check that the power supply drive was good before fitting the FETs. I just kind of rolled with it. I'm sure it's fine. Replaced all the drivers. There's nothing else that really could be preventing power supply drive. So let's just give it a brush over, make sure there's no solder bridges or anything like that. I think, 464 total solders. That's how many solder pins I've done on this amplifier so far. It's quite a lot, isn't it? Half 1,000. Halfway to 1,000 soldering pins. Yes, absolutely. Actually, hey guys, do you know what? I couldn't believe it. Someone sent me a Hyphonics amplifier for repair years ago. Hyphonics amplifiers have generally been pretty low build quality Maxonics garbage out of China. However, this one Hyphonics amp that got sent to me was freaking built like a tank, and it even had conformal coating across the entire board. It was sealed. Like condensation, no problem. You probably could have sprayed a freaking hose pipe at this board and it still would have worked fine. Yeah, and it had MOSFET clamps that had fins on them for dissipating heat. All the transformers were seated down properly. It had like the screw clamps on the inductors. The freaking board was thick as hell. It was great. I was like, yo, calm down, Hyphonics. Who do you think you are? It's a shame that it's so hit and miss. Like some of their amps have been like that. I've seen, you know, a couple of Hyphonics amps that have been like really well built, and then others that have just been total hot garbage. It's really hit and miss. But I agree. Yes, conformal coating would be a good shout, especially for colder countries. In car amplifiers and stuff like that would be a good shout for that reason. Yeah, for condensation reasons. Just kind of scanning over one last time just to make sure there's no solder bridges I haven't seen. Make sure everything is connected and good to go on the power supply side. Okay, cool. Now I've already removed the output FETs because that's what killed this amplifier, had dead output FETs. Removed those in advance. I'm just going to double check there's no solder bridges on the output side either, because we're going to be giving this thing full rail voltage now. So we don't want to kill the drive circuit any further than it might already be. Okay, cool, yeah, looks good to me. Alright, let's plug some power wires in and see what's going on with the output drive circuit. Joe said you've answered some questions from years ago. Oh, nice, man. Let me know what was the kind of things that you wondered from years ago that I answered without meaning to. Love to know. That's really cool. Lee says, my thinking wasn't even that. 2 amps behind my head. I didn't know which one went bang, so I thought protect will kick in. Yeah, that's fair thinking, to be fair. I just need to know which one went bang, and it went bang again. Yeah, man. Yeah, bad times. But at least now you know, hey. I'm wearing a Hyphonics shirt at the moment. Where'd you get that from? Does it glow? Amir, please tell me the Hyphonics shirt glows blue. Like has some batteries in it or something. That'd be freaking hilarious. Yes, the conformal coating sucks when it comes to repair. I agree. It's freaking annoying. You have to scrape it away before you can replace any components. Surface mount stuff is pretty annoying, but as far as like manufacturing process goes, it's cool. Oh yeah, well no. This is a different type of Hyphonics. I know the late 80s and early 90s Hyphonics was very high quality. That's not the Hyphonics I'm talking about. That Hyphonics is dead and gone many moons ago. I'm just talking about the new bullshit Hyphonics. But yeah, even some of the newer bullshit Hyphonics boards have been built pretty nicely. Obviously, the Hyphonics that was back in the day was a completely different company, completely different circuit designs, everything. Yeah, the only thing that remains the same is the name, unfortunately. Hey Sam, quick question. If I connect AC oscilloscope to the socket without the ground pin, will it equal to battery powered scope? Nope. Only if your oscilloscope is sharing a common ground with your power supply. So that's how I get away with it in the workshop here. You see me probing around on the amplifier. I've got no ground probe connected to the board. The reason for that is my bench power supply up here uses the same I have the negative terminal from the output of my bench power supply connected to the mains ground, so therefore that shares a common ground with my oscilloscope. It's a dirty way of coupling them. It's not the best way of doing it. It means that the oscilloscope screen has some noise on it, but generally the voltages that I'm probing with my oscilloscope are high voltage. Therefore, the noise is very low, very low amplitude compared to the voltages that I'm probing, so it doesn't actually get in the way. It doesn't prevent me from looking at the drive waves in any way, shape or form. So yeah, provided your scope and your power supply share a common ground, you can not have the ground probe connected. The only time you need to connect your ground probe is if you are probing very small, low voltages, very high frequencies, and you really need to see exactly the shape of the waveform. Then you would connect a ground probe to your scope and have it at a close ground reference to get rid of the noise that's on the ground path. Okay, remote wire next. Don't know about you, but I can smell like crisps. Like Doritos or something, you know? I'm pretty hungry actually, not gonna lie. Alright then, let's get this beast powered up, shall we? Let's just get rid of any possible solder that's chilling on my pad here. Cool. So what we are looking for, now we're going to power this up, what we're looking for is rail voltage in the correct places. So we've repaired the power supply section. It's going to create some nice rail voltage for us in the output section. The output section we have low and high side effects. So we've got low side in the middle, high side in the outside, I believe. So we're looking to have rail voltage in the correct places. If the rail voltage is not in the correct places, if we get any voltages where they're not supposed to be, then that tells us we have a drive circuit fault. So let's turn our power supply on. Let's keep the power supply voltage nice and low to start with. 9.6 volts is absolutely fine to get this thing powered up on the bench, just to get some rail voltage in the board. Nice low current, about 4 amps as well. So let's get our oscilloscope probe and have a look and see where the rail voltage ends up. So it's just pulse remote a couple of times. So we've got positive rail on the second pin of the high side FETs, which is where it's supposed to be. You love to see it. Now, that's not good. Okay, so that's what I was talking about. So over here we have the high side MOSFET location, okay? So the high side FET location is supposed to have positive rail on pin 2. Pin 1 and 3 are supposed to be 0. So pin 3 is 0, but pin 1, see, that's negative rail. And that means that one of the drive ICs over here on the driver card is toast. So yeah, there's no point in me powering the board up any further because the rail voltages are in the wrong place. So we need to repair the drive circuit before we can power it up any further. So to do that, what I should be able to do is just whack the board up here. I don't know if you're going to get a very good view of this. No, you're not going to get a very good view of this really, just because of how the board is angled. I wonder if we can angle it a little bit more towards. There we go, that might be a bit better. You're still not going to be able to see what I'm doing, but basically I'm going to replace the drive ICs on this driver card. All the other components are in the way, so you're not really going to be able to see what I'm doing, but at least you've got a little bit of a view. How can you tell if it's negative rail? Because it was the same amplitude as the positive rail. So I had about, what was it, 6 volts of positive rail, and I had 6 volts of negative rail that was leaking its way through onto the high side gate. So that means that the drive IC is shorted somewhere internally. Just kind of having a look around this board now at the screen, it's in the way. Oh man, you know what? I can smell something freaking incredible. I wonder if my other half is cooking a storm up in the kitchen right now. Usually, I'm going to grab a small handheld camera if I can remember where I've put it, so I can show you. Here we go. I'm going to show you what I'm doing, because we are all about that life, aren't we? We're all about showing you what we're doing. Plug in this USB-C. I need to get this up and running. It is HatCam, Logitech Studio Cam. There we go. Okay, so this is the output driver card. So I need to replace the 4 drive ICs on this card. Now, usually I get away with replacing these drive ICs without removing the driver card from the board because there's enough room here. In this amplifier, it's a little bit tight. I'm just going to grab my hot air gun and see how much space I've got to work with here. So if I'm going in at this angle here, so in order to get all of those pins desoldered, I'm going to have to be heating the chip up a fair amount. So yeah, I'm not a huge fan of that. It's a little bit tight. These inductors are a little bit in the way too much. I can't really get, like this one here is okay. This one over this side, I can come in from an angle and I can hit both sides of the legs pretty good. But this one here is okay as well. I can come in at an angle from the side. These ones here, yeah, I could probably do it. I could probably come in from an angle actually over this side. But yeah, it's a little bit tight. It's a little bit tight. So I think it might just be best to pull the driver card out entirely and just make sure that we're not melting anything by heating stuff for too long there. Oh, turning my other camera on has caused this one to go all jerky, like my man. Let's fix that real quick. There we go. they make 90 degree heat gun tips. Man, why haven't I ever thought of that? Why have I not ever thought of that? I need to get myself some right angled tips for the heat gun. Obviously. The basic solution. Why have I not thought of that? Oh, I know. I'll just 3D print myself some. I'll 3D print some right angled nozzles for my heat gun. That'll be right. Can't see anything wrong with that. This isn't going to come out easily, is it? Just my luck. Oh, maybe it will. My thing was blocked. There we go. Love to see it. Is it blocked again? There's a few different methods I have for removing these driver cards. One method I have is using the massive soldering iron and just like cooking it up and just letting it fall out, but that's not heated up right now. It takes like a good 10 minutes to get up to temperature, so I thought I'd just try it with the small iron and the sucker here to see whether I can do it. I've actually removed the silicone tip for this, which actually seems to be working a little better than with the silicone tip fitted, interestingly. I think it's because it gets held in place by the legs here, which is good to see. Sam, if you like bodging, you can bend a bit of steel brake pipe. Do I look like the kind of guy that has a bit of steel brake pipe laying around? Actually, I probably do look like the kind of guy that has a bit of steel brake pipe laying around. But I'm not really a car guy. I don't really enjoy working on cars much. So. Alright, that's most of the pins desoldered, but probably not all of them. Probably have to go back through some of them. Just give it a wiggle, see which ones move and which ones don't. You know what, by now I probably could have just waited for the big soldering iron to heat up and had it fall out by now. This is taking a little bit longer than I seem to remember. I seem to remember these being not that difficult to get out. I've got all of these ones loose over this side. I'm just doing these middle ones now. A couple of them that are still slightly tacked on. Also, doing it this way actually increases your risk of pulling the veers. So it's not the best way to do it. The best way is to flood these pins and just let it fall out. There we go. Okay, they are now all very wobbly in there. You can probably see it. So that should be all good to just pull out now. Hopefully we haven't taken any of the veers or any half veers with us, because yeah, there is a higher risk of that when you're doing it with this method. Let's have a look. Any pulled veers? Nope. Nice. Think we are good. Yeah, looks clean. Excellent. Excelente. I'm using the power supply from a crappy low power amp to power up the output section on this half bridge 8K. Yeah man, that's awesome. That's a really good method, isn't it? It's really good if you're troubleshooting a drive circuit fault and you don't want the high voltage rails present. Yeah, you can use a much smaller amplifier with the same auxiliary voltages to actually power it up. It's really cool. Love to see it. Okay, so what I want to do is on this board I just want to check the feedback bootstrap resistors here. You can go bad. So what we got on each one, I haven't got my multimeter cam hooked up today, so sorry about that. 1.2 ohms, 1.2, 1.2 and 1.2. So these resistors are all good to go. Grab the heat gun. Tweezers, where are my freaking tweezers, bro? Here we go. So I didn't actually check whether all these are okay or not. Ooh. Because these are in such ridiculous demand at the moment, what I might do actually is I might just drop that back in there for a sec. I might just try and see which one of these was the one that failed. I'm going to replace all 4 of them anyway for this customer, but any that survive I'm going to put to one side as like a kind of emergency supply in case anyone needs something repairing ASAP and they're all out of stock somewhere. So I think it was the ones on this side that were leaking or bad. You can generally tell whether one of these drive ICs is bad just by going across the bootstrap diode. If you get a reading both ways, like this for example, this chip's probably bad. So that might be the only bad chip. So let's remove that one just to make sure the short goes away. And the other ones may be alright. Okay, so let's have a look and see whether that's short across this bootstrap. Ah, okay, it hasn't. So the bootstrap diode failed. Now, this is where I was saying earlier, you never really know. You never really know what caused the amplifier to fail. Whether it was as a result of a drive IC giving up, or the diode failed first, or whether the diode failed because the output FET shorted. Like, you never really know. I'm just going to put this back in place just for a brief sec, just so I can take the diode out and see what readings we get with the diode removed. So we still get a low resistance with the diode removed, so I suspect the chip's bad as well. Okay, let's have a look at some of the others. So yeah, this one seems alright. Let's go over a little bit to the others. Seems alright. Seems alright. So we can't be absolutely certain that these other IRS218441S chips are okay or not. But I'm going to put them in my possibly okay emergency spares drawer anyway. We're going to replace all 4 of them for brand new ones. I'm also, at the same time, going to replace all of these bootstrap diodes because we're not sure whether it was the diode that died and caused the amplifier to fail, or whether it was the FETs or the chip or whatever it is. But just in case, we're going to replace everything. We're here anyway, we might as well. Mr. Big, nice man. I'm glad that it turned out okay. Good morning from Pittsburgh. How's it going? Living loud. Thanks for jumping on. All right. So, where's my drawer for those ones? Go on, there it is. So I'm going to put these 21844S chips in the emergency drawer. These were batch 803P. Okay. Here I have some of the older IR 21844S. I don't know whether these are... where did I get these from? Let me check my emails. Right, so if I search my emails for IR21844, I just want to double check where I got these ones from, because I can't exactly remember. There was one point where I got some of the IR models from AliExpress, so I want to make sure that these aren't those ones. I think it was quite a while ago now. I don't want to drop any AliExpress chips in this amp, so... don't think these are the AliExpress ones, because I think I got a massive tub of those, and I think they're somewhere else out of the way so I don't accidentally use them. Hello Sam, jumping in right now. Driver card issue you're working on? Yeah, just a standard everyday Korean half bridge failure. Just replacing the 21844S's and the bootstrap diodes on this one. I'm just making sure I put parts that I trust into it, because I've got a few different batches here of chip that I want to make sure I do right. Here we go. What did I order? 10 pieces. That was in that was last year from eBay. Did I really? That 10 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 here, so that's not those. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, I've got 12 of them here in this little packet. So I was just they're not PDF. Here we go. I bought some from Farnell in October last year. I bought 12 of them, and this is 12. Excellent. So these are ones I can trust then. These are from Farnell. Love to see it. Excellent. That's what I'll drop in place then. I wish you'd seen that. That was so satisfying. I'll do it again. I'll do it again on camera. That was really satisfying. I love taking new parts out of their packet. See you later, Lee. Thanks for jumping on, buddy. Really, really love to have you here, man. Alright, so just going to freshen up these solder pads, get them nice and fresh with some fresh 4060, ready for our new chips. Sam, I was right. After done some research on the 28 EQ card installation, you need to take away 2 jumpers to install the risers for the card. So I put back on the 2 jumpers and now I have audio. Excellent. Well, maybe you'll be able to help us with where those jumpers go. I won't be looking at those today though. Today is just this amp here that I'm working on. Alright, cool. I think that's all good. We just want to go around with the multimeter probe now, just make sure that all of the pins are soldered properly. Yeah, looks good to me. And now we need some more bootstrap diodes. So the ones that came off this were U4C. These boards usually have, I think it's X3s. U4C diode. Just want to make sure that that's correct. MURA 115 T3G. Is that what this is? What other ones do we sometimes see? It says X3 on it sometimes. $150 ultra fast recovery. Doesn't seem like high enough voltage to me. What about you? ES2GA. So the MURA 115 is a 150 volt part, and the ES2, which is often used, is a 300 to 400 volt part. Okay, yeah, I'm going to use some slightly high voltage diodes on here because this is a 5K. The rails are kind of high on this, so yeah, that could have been an issue there. So let's see what I have. I think I've got some U1Ds, which I can't remember what the model of those ones are. U1D diode. U1D. That's a 200 volt part. Okay, I want a 300 or 400 volt part ideally though. Let's see what I've got. I need an ultra fast rectifier in high-ish voltage. I do have some on this board that I can steal, but I don't want to use used parts. See this one, I got a spare board, so I could just take these ones, but they're used parts. I want to use all new parts for my man here. See what we got in the big drawer, the big box of diodes. We've got some U1D, which I think these are the 200 volt ones, yes. So yeah, I want something a little higher voltage than that ideally. These are U4Cs, those are 150 volts. So it looks like I might need to actually buy some more. I need to buy some replacements. So I'm going to buy some 300 to 400 volt bootstrap diodes here. So I need some new output FETs because I haven't bought those yet, and new bootstrap diodes. So that's as far as we can get today with this amplifier, guys. It's been a pleasure. Thanks very much. Let's have a look at some live chat real quick. Personally, Daniel, I don't think I've experienced any issues with overheating the 2010s. The 2010s were actually the first ones I ever learnt to repair on, because those are the Banda Viking 7K chips that they use. And yeah, I was definitely not careful with the hot air gun when I was doing those, and I haven't had any issues with the chips dying after being installed, so yeah, it seemed alright for me. Alexander says, I have an impedance question. Fire away, my friend. Fire away. Let's have a listen. What do you think of a downfire in backseat area of a convertible soft top? Downfiring sub in the backseat area of a convertible soft top. Yeah, convertibles are difficult to, get the same amount of bass that you would get from a hatchback or something, just because you don't have cabin loading properly. You don't have the advantage of cabin loading in a convertible. So really, the bass you're going to be listening to is near field. You're going to be listening to the the primary wave emitted from the sub, rather than a reflection or some kind of loading standing wave thing. So, from my experience, I've generally found that sealed boxes have a really nice near field response. Same as passive radiator boxes. Ported boxes, although they can get they can be a similar loudness close up, you tend to really hear the port, like whether it chuffs or you just hear kind of noise from the port. I'm not a big fan of it. I'd much prefer listening to ported boxes from a distance. And there's something about ported boxes, they just seem to want to load off something. I don't even know what it is, but I much prefer listening near field to waves radiating from a large surface area. So whether that is a cone from a sealed box, or whether that is from the cone of a passive radiator. The passive radiator is the same as a ported box, just with a limited displacement, but I don't know, there's something about it that just nicer and just sounds better, to me at least, in my experience. Like, could be complete nonsense, but just from what I've noticed. So I would probably, if you're going to do something in the back of a convertible, in the backseat area, sounds like you probably haven't got a bunch of space to play with, so I'd probably do passive radiators. I'd probably go with something like a single 12-inch woofer with a pair of 12-inch passive radiators, like a nice compact square cube box style thing with the passive rads either side. Maybe a pair of 10s with a pair of 12-inch. Yeah, a pair of 10-inch drivers with a pair of 12-inch passive rads might work quite nicely as well. Yeah. Or just something sealed. And a bunch of power. Obviously with sealed you need power, really. Alexander, I personally can't say that I have heard a significant sound difference on 1 ohm versus 4 ohm. Only that 4 ohm doesn't sound as good because you can't get it as loud. The main defining factor in how nice a sub setup sounds is dynamic headroom, and with 4 ohm you're obviously going to be massively limited on power compared to 1 ohm, so it generally doesn't sound as good when you crank it up. But I haven't done the experiments to back up that statement, so there very well could be very audible differences. But just in all the testing that I've done, in the past I've gone from 0.5 ohm to 1 ohm to 4 ohm to 8 ohm in my various different builds using the same subs, just changing the ohm load to see what changed, and I couldn't really tell a difference in sound. So yeah, guys. Thanks for keeping me company here during this long-ass population of this Sundown 5K. Appreciate your time. Appreciate you jumping on live stream with me. Always a good time. Yeah, I'll see you soon. Possibly tomorrow or Thursday for a boom or bust. I'm thinking for the next episode of boom or bust, we just test a sealed box. Here is the sealed chamber from the Fibonacci 4th. I'm thinking we just see how a basic sealed box does in the test cabin, just as a reference more than anything, just to kind of see what that's like. Yeah, that might be quite interesting. Means I haven't got to print anything new, of course. And then after the sealed box, might do a 6th order shootout or 4th order shootout, or do some regular kind of ported boxes, something like that. Really? Where is there an air leak? Ooh, it's ever so slightly leaky around there. Didn't know that. Okay, cool. I'll sort that out.